Okay, we're adding on to our transformation and parent function notes. The most important page in this whole thing is right here, the transformation rules. And so every function obeys these rules, which is why it's the most important. So if you notice where the adding and subtracting is taking place, that's the key. So it's adding h on the inside of the parentheses. Whatever the function is, doesn't matter. If it's adding some number inside the parentheses, then it will shift it to the left, whatever that number is. So it shifts left h units, whatever h is. And if there's a number subtracted inside the parentheses, then it's going to shift it to the right. Whatever that number is. If there's a number added or subtracted outside the parentheses, then it will shift it up or down. So this will go up, whatever k is, up k units, and this will go down k units. So if it's added, it goes up. If it's subtracted, it goes down. So the two things that are inside the parentheses, whenever there's something inside the parentheses, it's going to affect the x value. It's going to, if it's inside the parentheses, it changes the x. If it's outside the parentheses, then it changes the y. So that will go for anything. If it's inside, it changes the x. If it's outside, it changes the y. Next group is dilations. So we have a number multiplying on the outside. So it's outside, so it's going to change the y. If a is bigger than 1, the absolute value of a is bigger than 1, this would be multiplying a number. This is going to stretch the function in the y direction. So it's going to stretch it up. If a is less than 1, this is a fraction, so this would be division. So if a is less than 1, you're going to have a fraction, which is division, and that's going to compress in the y direction. Compress. And then finally the reflections. Notice the negative is outside the function, so it's going to change the y value. Right? So this is going to flip it upside down or across the x-axis. It's going to flip across the x-axis. Then I want you to add, if there's a negative inside the parentheses, this is going to change the x value because it's inside, so it's going to flip it across the y-axis. And let's also add a dilation, because you could have a dilation on the inside of the function, and it's going to stretch it or compress it in the x direction. And again, it's backwards. So if it's multiplying, it's going to compress it. If it's dividing, it's going to stretch it. Okay, so this stretches or compresses in the x direction. All right, which every time you have an x change, it's backwards of what you might think. So multiplying would be the compressing, dividing would be the stretching. Adding changes to the left. Looking up here, when you add, you move to the left. When you subtract, you move it to the right. So the x is always backwards. Okay, so now we're going to be looking at the absolute value function. So there's your parent function. Have that handy so you can see it, because we're going to use it to graph this new function. And I want you to describe the transformation and then graph it. So the transformation is based on those rules that we just looked at. So there's a number in front of the there's not parentheses, there's absolute value bars, but they do the same thing as parentheses. Okay, so there's a number multiplying in the front of these absolute value bars. So what do your rules tell you to do? They say that's going to stretch it in the y direction. Right? So this is going to stretch the y times 3. Okay, and then what does that minus 4 inside the function do? Whenever it's changing the x, it's backwards. So instead of going to the left, it's going to the right. So this is going to move it to the right 4. And what's this minus 6 on the outside do? It does what it says. So it's going to move down 6. Okay, so there's our 3 things that we needed to describe. And now we can graph it. So the first thing that I would like to do is change the vertex. So the vertex is at 0, 0 originally. The shifting right and down, that's going to move the vertex over. So I move the vertex to the right 4, 1, 2, 3, 4, and down 6. 1, 2, 3, 4, 5, 6. So there's my new vertex. Now to get the points, I'd move from the vertex. To get the next point, I would go up 1 and right 1. So I'm looking back at the original function. So up 1, right 1, and then up another 1, right another 1. So from the vertex, now it's not going to go up 4 because, sorry, it's not going to go up 1 because of that stretch. Right, it's going to go up 3. 1, 2, 3, and then right 1. Now the x direction is not getting stretched, so it's just to the right 1. And up another 3, 1, 2, 3 over 1. And I could continue doing that as long as I want to. And then it's also going to go up 3 and left 1. Up 3 and left 1. So there's our new absolute value function. Okay. Then where's the vertex? Well, the vertex got moved where the whole shape got moved. So it went to the right 4 and down 6. So the vertex is going to be at 4, comma, negative 6. Okay, what's the domain? The domain is all the x's. So I can plug in any x that I want to. X continues to going to the left forever, and it continues going to the right forever. So we just say all real numbers. The range, though, does not go down past negative 6. So the range is going to go from negative 6 to infinity. We want to include negative 6, so put a bracket. And the rest of those I'm not too terribly worried about. So let's just focus on these for now. So next we're going to look at the quadratic function. There's your parent function. Keep that handy. And we're going to graph this new function. So you look at it and describe the transformation first. So where is it moving? The negative in front says it's going to get flipped upside down. It's going to flip across the x-axis. And that positive 1 on the inside doesn't move it to the right 1, it moves it to the left 1. It's going to go left 1. And the positive 4 on the outside is going to go up 4. Okay, so that's our movement. Now we can go ahead and graph this. And I always start with the vertex. So the vertex is moving left 1 and up 4. So go left 1, up 4. Oops, that's only a 3. Put your dot. And so that's our vertex, right? So you could answer that vertex question. I mean, just take the vertex from here. You take the opposite of the h value and then take the k value. So negative 1, 4 is the vertex. And it's shifting, or it's not shifting, it's flipping upside down. So go back to the parent function, the original. To get to these next pair of dots, you're going to go up 1 and right 1, right? Or up 1 and left 1. So from our vertex, we're not going up because we're flipping upside down. So we're going down 1 and right 1, down 1 and left 1. Okay. Then to get to the next pair of points, from these we would go up 1, 2, 3, and over another one. So instead of going up, we're going down 1, 2, 3, over another one. Down 1, 2, 3, over another one. And that's enough points for a good quadratic graph. So there it goes. Okay, so what's the domain? What's the range? We already did the vertex, right? Said -1, +4. Domain, the x value continues forever to the left, continues forever to the right. So the domain would be all real numbers. The range does not continue forever up, right? It stops right there at y equals 4. So the range goes from 4 to -infinity, but we generally start with a small number first, so -infinity to +4. And we want to include that 4, so I put a parenthesis, but I should have put a bracket. So there's our quadratic function. So next up we have the cubic function. There's the parent function. Again, have that handy. We're going to create a new cubic function because I don't like this one. So let's just do f of x equals x minus 2 cubed plus 4. So there's the function that I want you to graph. So the transformation, what's it doing? Okay, there's a -2 inside there. It doesn't move it left, it moves it to the right. Because the x is always opposite. So it moves to the right 2, and then that +4 is moving it up 4. Alrighty, so we're taking that center point and moving it to the right right 2 and up 4. So 1, 2, 1, 2, 3, 4. So there's our new center point. All right, so these next points, where are they in relation to the center? Well, they go up 1 and right 1. So they go up 1 and right 1, and then down 1 and left 1. Down 1 and left 1. Now to get the next pair of points, this one at the top is going to be up above, too high on our graph, but the bottom one we can get. So from the last point, it would go down 1, 2, 3, 4, 5, 6, 7, and then left 1. So 1, 2, 3, 4, 5, 6, 7, and left 1. All right, so there is our new cubic function. Looks something like that. All right, so what's the domain? The domain the x goes forever to the left and forever to the right. So the domain's all real numbers. The range, same thing, goes forever down, forever up, all real numbers. So next up we have the square root function. And to graph this, again, you're looking at where is it changing? What is it changing? Where is it shifting? And then is it flipping it or dilating it? So this +5 is going to shift it to the left 5. And this +2 is going to shift it up 2. And then this negative in the front, don't forget about him, he's going to flip it upside down. So it's flipping it across the x-axis. So where's this going to go? So our basic function starts at 0, 0. The shift is going to move the endpoint left 5 and up 2. So move it left 5, 1, 2, 3, 4, 5, up 2, and there's our new endpoint. Then if you look at the parent function, from the endpoint, it goes up 1 and over 1 to get to the next point. So from our endpoint, we're not going to go up because it's getting flipped upside down. Right? It's flipped across the x-axis. So instead of going up, we're going to go down, but we're still going to go over 1. So we got our endpoint, we got our next point. Then to get to the next point, it's going to go up. I'm back at the parent function. Go up 1 and then right 3. But again, you're going down. So we go down 1 and then right 3. And then we can get our next point. So down 1, right 3. There we go. And that's enough points to get a good square root graph. So it's going to look like that. So notice it is very similar. It's just upside down and shifted. Okay, so the endpoint for it shifted to the left 5, so that's going to be -5, and up 2, so that's a +2. So there's your new endpoint. And what's the domain? the x starts at -5 and it goes through infinity. Right? So it's going to be from -5 to infinity. Then the range goes down to negative infinity. So that's as low as it goes. Right? It never stops going down. And it stops going up at +2. So we got from negative infinity to 2. Then next up we have the cube root. There's your parent function. And here is our new function. So where's this shifting? So the -1 on the inside says to go to the right 1, and the +3 on the outside says to go up 3. Okay, but that's not all. This one has a -2 in front of it, so that's multiplying by -2. So this does two things. The negative flips it, so flips it over upside down, and the 2 stretches it. So it's going to stretch it, stretches the y by a factor of 2. So every y value will get multiplied by 2. All right, so let's take a look over again at our parent function. It looks like that. So the central point is at 0, 0, but it's not going to stay there because we're moving to the right 1 and up 3. So that's our new central point. Then to get to the next point over at the parent function, looking again. So this would go up 1 and right 1, but ours is getting flipped upside down, so it goes down and right, and it's getting stretched by 2, so it's going to go down 2 and right 1. So the flip makes it go down, the stretch makes it go by 2 instead of by 1. Okay, then let's keep going from there. Go up 1 and right 1, 2, 3, 4, 5, 6, 7 to get to the next point. So the 7 stays the same, but the going up 2 is going to get flipped and multiplied by 2. So it's going to go down 2 and right 7. So down 1, 2, right 1, 2, 3, 4, 5, 6, 7. That's where we put our dot. Okay, going back the other way is going to be very similar because it's symmetrical. So it'd go down, down 1, left 1. So instead of going down, we're going up 2 and still left 1. And then we would go up 2 more and left 7. 1, 2, 3, 4, 5, 6, and 7. So there is your curve. So the turning point, this is like the center point, and that's straight off of, look at the equation. Right? These numbers here will give you the center point. So that center point is at +1 and +3. The domain goes forever to the left, forever to the right, so that's all real numbers. Range, all real numbers as well, goes forever down, forever up. And next we have the exponential function. So the domain for the exponential, x continues to the left, x continues to the right forever, so it's all real numbers again. The range does not continue down forever. If you remember from previous day's video, this function does not get to the x-axis. Never actually touches it. So it starts at 0, but it goes up forever. Now I'm not going to include the 0. I'm going to put a parenthesis there because it never actually touches the x-axis. So with that in mind, it never touches the x-axis. So there is no x-intercept. Right? If it never touches it, there isn't one. The y-intercept going through the y-axis there at y equals 1. So there it is. The increasing interval as you're walking along that function, you're going to be going up everywhere. Right? So you start increasing at negative infinity, and you never stop increasing. So there's your increasing interval. Then if it's always increasing, it's never decreasing. And as x goes to infinity, where does the function go? As x goes to the right, the function is going up. As x gets bigger and bigger, the function is getting bigger and bigger. So a few different ways to think about it. As x is going to the left, as x is getting smaller and smaller, where does the function go? It's not going to continue going down forever. right? It stops going down. It doesn't go down past the x-axis. So your function is not going to go to negative infinity. It's just going to go down to 0. It's going to get really close to 0, but never actually get there. And that is what we call an asymptote. So this asymptote is where y equals 0. This is also the x-axis. So the last one, the last one we're going to be working on is the reciprocal function. You may have noticed we skipped the logarithmic, but don't worry about that one. So the reciprocal function is 1 over x. So the domain of this thing is almost all real numbers. But if you remember from the previous day's video, 1 over 0, you can't divide by 0. Right? 1 divided by 0 is undefined, which means the x value of 0 doesn't work. So the domain is almost all real numbers. It's all real numbers except x does not equal 0. And if you look at the graph, you'll notice that on the y-axis, those two curves don't touch the y-axis. And then the range, it's very similar. You notice that the two curves do not touch the x-axis, so it's all real numbers except y does not equal 0. Okay, then the x-intercept and y-intercept, we just got done saying that they never touch the x-axis, so there isn't one. And they never touch the y-axis, so there isn't one. The increasing intervals and decreasing intervals, as you come from the left to go to the right, you'll notice that both of these pieces, both of these segments, will be decreasing. Right? They're always going down as you go to the right. So there is no increasing interval, but the decreasing interval for the first section, so there's two sections to it, so you're going to have to give me an interval for both of them. The first one starts at negative infinity, and it goes all the way till we get up to 0. Even though 0 isn't part of the graph, I mean, it gets really, really close to 0. And then on the other side, it kind of starts at 0 and goes all the way to infinity. Is where it's decreasing. So the end behavior, as x goes to infinity, where does the function go? So as x goes really far to the right, the graph gets really close to 0. Right? So we just say it approaches 0. And then on the other direction, as x goes to negative infinity, as x is going to the left, the function is also getting really close to 0. Okay, so for these, you're going to have a vertical asymptote and a horizontal asymptote. So the vertical asymptote is the y-axis, which is where x equals 0. Okay, so I would also note that that's the y-axis, but it's technically where y equals 0. The horizontal asymptote is, the vertical asymptote is where x equals 0. The horizontal asymptote is where y equals 0. And that is the x-axis. Okay, so that's the last one of the graphs that we're looking at for today. Tomorrow we'll finish the rest of the booklet.